Okay, so let's start with a toy example. I'm going to get folks to put their choice in the chat, but here's the problem that we're going to try and solve. We have $10 million and we're going to spend that money on saving species. We can save the southern resident killer whale, which is shown here, and we have some idea of its population size and its trajectory over time, its expected trajectory. Or we can spend our money on the burrowing owl, and this is its trajectory in blue. We only have $10 million. Each species costs 10 million to save. And the question is, which species should we save first? I want you to put your choice in the chat. There's no right or wrong answer, but I just want to know what would you choose given this amount of information that you have? Which species would you choose? Who would choose the orca and who would choose the burrowing owl? Okay, we got an owl, we got an orca, we got orca. So some for the orca, lot for the orca. Okay, Rashid would say, I'll choose half of each. Nice. Okay, for those, so for just someone that chose the orca, can you give a quick, turn your mic on and just give me a quick reasoning, why did you choose the orca? Again, don't be shy.
Tara, you had a big laugh, right? Half of each. Yeah. Oh.
I love it. I love it. So who wants the orca?
Yeah, I want the orca because it is more based on my personal preference. I love the oceans and I know about the orca and what facts they are facing. So that's why I care more about the orca.
There we go. Yeah, because you have a connection. This is a species that you care about, that you value. You understand the ecosystem, and maybe also there's, if you save the orca, you might be saving some other things that share that habitat with the orca. Who went for the burrowing owl? Anyone want to just quick, why the burrowing owl?
Yeah, I picked the burrowing owl, and yeah, I was gonna go for the orca, but I thought that most people would go for the orcas.
Great. So I like that. So you've going for the underdog. Giuliano also put, because it has a higher chance to survive because it's crashing later in time. Okay, I really like that because sometimes people choose, they say, oh, we're going to choose the orca because it's more critically endangered than the owl. So there's interesting perceptions about the importance of time here. All right, so we've got our 10 million, but now, like Rashid said, we can spend our 10 million on the orca, or we can spend 5 million on the leatherback turtle and the burrowing owl and save 2 species for 1. Who's going to switch and get a 2 for 1? Anyone? I'm going to do, okay, Colette says I'm going for the 2 for 1. So this is an extremely simple example, but these are the types of problems that we're actually trying to make decisions about. And here in Canada, we have over 850 species at risk listed under the Species at Risk Act. And these are truly the types of questions that our decision makers are faced with. They have a fraction of the resources that are needed to recover those 850 plus species. And they have to decide how are they going to allocate their insufficient budget to those species. And that means making some very, very challenging decisions, often under huge amounts of uncertainty, because we just simply do not have the data that we would like to base those decisions on, and we don't have the time to collect that data in a timely way. So decisions are very hard in conservation. They're embedded in these complex social ecological systems. There's often multiple objectives and they often conflict. We have these known and unknown uncertainties. There's many different decision makers, stakeholders, rights holders, and these decisions require an integration of our values, of policy that's in place, and the science. All right, so what is an actual decision? Anyone? What's a decision? Just quickly in the chat. What would you define as a decision? Anyone want to have a crack at it? A choice of action, making a choice. Yes, great. So a decision is a choice between two or more alternatives, okay? If you only have one thing to do, if there's only one thing to do, then it's not a decision. You just do that one thing. But if you have two or more choices, then that is a decision. All right, so then what is decision science? Decision science is a whole field of research about how humans can make decisions. And it spans a whole range of fields from operations research, economics, mathematics, computer science, ecology, philosophy, psychology. It's across almost every discipline. Decision analysis is really the application of decision science. You'll also hear this term structured decision making. Decision analysis and structured decision making are the same thing. It's just that in natural resource management, ecology, conservation, the folks that work in this space, we often call it structured decision making. So you'll see that term come up and just kind of have a mental note, oh, that is decision analysis. They are synonymous. This is a paper led by Victoria Hemming, and this is really the primer. So if you want to know more, this is the paper to go and have a look at. It gives a really good overview of the field and the various applications in the field. So decision analysis is essentially these 7 steps, and it's broken into this acronym PROACT. And PROACT essentially starts with problem definition, that's the PR, and then it's around eliciting objectives. So we define our problem that we're working on. We then elicit the objectives, the things that we want to achieve. Then we develop our alternatives, which are the various actions we can take to achieve those objectives. Then we estimate the consequences of taking any one of those particular actions and how they perform against our objectives. Then we do some modeling and evaluate the trade-offs between taking these different actions. And then we decide and implement and monitor and learn. So that formulation, that is decision analysis. Now, the thing that differs is in each application. So for each stage of that process, there's a whole bunch of different tools that we can use. And so for each component, we can choose a bunch of different things that we can do depending on the type of problem that we're trying to solve, and depending on our own analytical skills, and also depending on the resources and the time that we have to solve this problem. So each of these steps has a bunch of tools, and the different combinations of these tools that we can use in a decision analysis is really what defines some of these key decision analysis frameworks. So you may have heard of systematic conservation planning, which is basically the spatial application of decision analysis. So it's deciding what actions are we going to take across space, say to design a protected area, a marine protected area. Which parcels are we going to give a particular designation? That is a type of decision analysis problem. I just wanted to flag that one of the reasons why we have these structured ways to make decisions is because there's a lot of biases that affect our ability to make good decisions. And each of these biases could be a whole presentation on its own. But for example, we have things like anchoring bias. So, if we go to the shop and we want to buy a mug and the mug has a price tag of $1,000, and then we see it, another mug for $300, we think, geez, that mug is a great deal. But that's because we anchored on this other price. And retailers do this all the time. We have other biases, common one around groupthink, where we're in situations where we're working we're in a workshop or we're in a seminar. And, if everybody's kind of in agreement, except for, you might be thinking, I don't actually agree with that statement, but there's a lot of pressure to conform. And so these are the different types of things that can affect ultimately the way we make decisions. So I'm going to walk through an example pertaining to endangered species, and I'm going to show you an example of a decision analysis framework that my team has developed and has been applying around the world to help inform the recovery of species at risk and species of conservation concern, species of cultural importance. And the reason that we developed this framework was recognizing that really current approaches to the recovery of endangered species are not working. In fact, many of them are failing. And so why is that? Why is the Species at Risk Act not achieving what we want it to achieve here in Canada, for example? Well, a big reason is that it just takes too long. We have processes that are so bureaucratic and onerous that it just takes too long to actually make a decision to get to the point of taking actions in the sea or on the land to recover a species. We also have this issue that we focus on single species. So we have recovery plans and action plans that are specifically for a single species. However, when you look at the types of threats that species are facing, they're often the same. And so if we were to take a different approach and actually focus on multiple species, we may end up saving a lot of resources and saving a lot of species. We also prioritize the wrong thing. So we focus on prioritizing species, but it's not the species that are using the resources. It's the actions that we take to save species and ecosystems that use those resources. And so we really should be prioritizing the actions, not the species themselves. So let's just unpack that a bit. So here is this framework that we developed. We call it priority threat management. And because it's about prioritizing the threat management strategies that we should be taking to recover species or ecosystems or things that we care about. And we've written a bunch of papers on this, if you want to follow up on any of them. But essentially it does this. It prioritizes the actions for species and ecosystem recovery by their cost effectiveness. So in other words, what actions can we take that are going to be the most effective for the least cost to society? It informs the most cost-effective actions to take and where to take them. It calculates the cost of recovering all species. And it also calculates how many species or populations we can recover for a given budget. So it can show us what that shortfall might be. You know, how much money do we need to save everything, and how much money, what's the best thing we can do with the budget that we have. And it's relatively fast and inexpensive. In fact, it's very fast and inexpensive compared to species at risk planning under the Endangered Species Act or under the Species at Risk Act. So when we go back to this decision analysis framework, there's some key tools that we take to undertake a priority threat management. So we start with the stakeholder analysis in terms of defining the problem. We then go into literature reviews, conceptual models, brainstorming to define our objectives. And then we use consequence tables and expert elicitation to build our consequence tables. We draw on cost effectiveness analysis, complementarity analysis, and multi-objective optimization. And then we undertake some sensitivity analyses. So this is a process that I developed with my postdoc, Josie Kawadine, way back a long time ago, back in Australia, over a decade ago now. And we've applied this process to about a third of the Australian continent. And in each application, we develop essentially a prospectus. So this prospectus is really identifies all of the actions, the most cost-effective actions for saving species and ecosystems in a particular region. In Canada, over the last 6 years since I took up a position at UBC, we've applied this process to 8 case studies across Canada, from the St. John River, New Brunswick, across to Central Coast and Lower Fraser and Kootenay bioregion here in British Columbia. And again, in each case, we've identified what are those most cost-effective actions to lead to the highest likelihood of recovery for species and ecosystems in these regions. So let's look at this example. So many of you will be sitting in the frame of this photo up here, either at UBC campus or around here, and I'm sitting down here on Salt Spring Island at the very southern end. This region is a big chunk of the Sailor Sea. It's one of the most biodiverse regions in all of British Columbia. It's also one of the most threatened regions in British Columbia because it's where most of our industry and where most of our population lives. But despite the enormous impacts occurring in this region, it's still home to many, many species, and many of those are at risk. It's home to over 30 nations since time immemorial. It is still the basis for many people's livelihoods in the fishing industry, and supports 102 species at risk of extinction, from species of salmon to southern resident killer whales, blue and green sturgeon, many, many migratory birds, and other species. So there's a lot going on in this area, aside from it being a biodiverse region, a region that's been occupied for thousands of years because of its biological richness. It also has a bunch of things going on which cause a lot of stress to this system, from agricultural intensification, urban and industrial development, gravel mining, sea level rise, and temperature increases. And then there's a whole bunch of other stuff that's happening right now or proposed to happen. You know, LNG export terminals, this proposed Terminal 2 port expansion, proposed coal export terminal. So there's a lot going on. Things are already hard for species in this area, and things could get harder. So we start by defining what is the problem that we want to solve here. We've got 102 species at risk. We need to define a time frame. So we want to discover the actions needed to save these species, to make sure that they are going to persist. And when I say persist, it means that these species they're not going to be just one or two individuals around, but they're going to be self-sustaining and thriving in 25 years' time. We've got a very complex governance space where we have multiple levels of government. We have many nations, many decision makers, and many industry stakeholders. It's complex, it's biodiverse, and it's a highly contested region. So here's our objectives. We want to maximize the persistence of species. We want to minimize the cost of those management actions. And we want to maximize the feasibility of those management actions. Okay, and feasibility is two things. It's the social political feasibility that an action would be implemented, but it's also the technical feasibility that if I undertook that action, it would achieve its expected benefit. So let's just look at a few of the potential strategies that we could take to help recover species in this region. So we have one around this is really invasive species. So we have a strategy around dealing with invasive species. We have a strategy around aquatic habitat restoration, one around pollution control, aquatic disease control, transport regulation, and there's a whole raft of other strategies. Each of these strategies can get broken down into very specific actions that you take. And the assumption is that if you choose a strategy, you must undertake the actions within that strategy. So this particular strategy includes, a marsh restoration project that's 20 hectares, a connectivity project around the McDonald Slough Dike, etc. So we've got our problem definition. We have our different strategies we can take with their underlying actions. The next thing we need to do is predict the consequences of taking any of those actions on achieving those objectives. And so how do we do that? Well, classically, we would go and implement some field research, go out into the field to collect data and start to understand what the potential impact of an intervention would be on those species. This is one of my former PhD students out in the Fraser collecting water quality data and for her work on juvenile salmonids. This is a former postdoc, Megan Adams. She's out collecting bear hair, looking at different strategies for salmon and bear conservation on the Central Coast. This is really important work, but the take home here is we just simply don't have the time to undertake all of these studies and estimate the consequences of all of these potential alternatives on all of the species that we're trying to recover. And so this is where we turn to expert elicitation. And a lot of the work that I've done and that Victoria has been, her whole PhD was on in this field, is how do we elicit expert judgments in a good way, in a way that we're getting data that is close to the truth, and has relative, is not so uncertain to be useless, but has we're still able to capture that uncertainty. How do we do that in a good way that's repeatable, that's robust? And this has led to the development of a lot of very structured ways of eliciting information from people. And we don't have time to go into the details of those, but I encourage you, there's some very good papers led by Victoria and others around how to do that work. So here's an example of an expert group. This is all of these folks in this image know a lot about salmon. And so we brought this group together at UBC for 4 days to to talk about and explore what are the different strategies we should be taking to recover salmon in the Lower Fraser. This is another group in the Salish Sea where we spent 4 days on Salt Spring Island talking about what are the strategies we need to take to recover endangered Garryoke ecosystems in the Salish Sea. In each of these expert groups, we're trying to get a very diverse cross section. So we have Indigenous knowledge holders and elders. We have government scientists. We have academics. We have young and old. We have mix of genders. Diversity is key. That's one thing that the research in the space has shown, is that in order to get the most robust and information closest to the truth, you need a very diverse group of experts. And this runs contrary to often what we see in expert groups, which are usually older white men. And all of the research suggests that those groups are not going to deliver the types of results and information that are going to guide the best decisions. So creating the space to have these conversations is also another really important part of the process. Just bringing people together into a very sterile, institutionalized environment can be very trauma-inducing for people. And you may not get the people that you ultimately want to have in the room if we don't create the spaces that are inviting and the conditions that make people feel safe. And so this is something that we've really been focusing on too, is how do we create these trauma-informed spaces that everyone feels welcome and everyone feels cared for, and therefore able and willing to share conversations about cumulative impacts to ecosystems, to species, can be very triggering, particularly for Indigenous knowledge holders and elders, because those decisions have led to so much loss and trauma in their own communities. In order to create these spaces, we work with artists, we work with videographers, we work with Indigenous facilitators, and through that, we're able to gather information in such a way that it not only does it help inform the science that we're doing, but it actually provides records and archival material to give back to community. So this is Bryony Penn. She's an extremely gifted artist and also author. And she has an incredible ability to illustrate some of these very complex concepts that come up in our conversations. So this was a workshop we held with Newhawk First Nation, and where we're talking about cumulative impacts of to old growth, and these concepts of dividing and conquering, logging, changes in pollination, changes in climate, and this issue of governments driving a wedge between nations in order to divide and conquer. So that is another aspect to this decision analysis, which I think is something that our team is really exploring and starting to build that into these decision analysis frameworks. So if we go back to the analysis, so we've got for the Fraser River estuary, we've got our problem defined, we've got some strategies that we can take, we're going to estimate the consequences, and now we want to apply a technique called cost effectiveness analysis. And this is a simple way to identify what are the most cost effective actions we can take. And cost effectiveness analysis is really very similar to cost benefit analysis, except for this benefit is not an economic benefit. The benefit here is that thing that we're going for, which is the improved probability of persistence of the species or ecosystem over time, given a particular strategy. So it's that benefit of action times the feasibility, the technical feasibility, and the social political feasibility of an action divided by the cost of that action. So if we can estimate the benefit, well, how do we estimate the benefit of taking an action? Well, first we require essentially two predictions. We have this probability of persistence of a species. We have our time frame over 25 years. And the first thing we need to know is, what is the probability of persistence of the southern resident killer whale given the status quo, given what's going on right now? So no additional strategies. Well, how is it going to do in 25 years' time? And then we ask, well, if we were to implement this transport regulation strategy, what is the potential probability of persistence with that strategy? And then the difference between those two estimates, that is the benefit of that transport regulation strategy for orca. We run that expert elicitation for every strategy and species, and then we build up the cumulative benefit of a particular strategy for all of the species that are in the analysis. We can use spreadsheets. You know, as often we'll have a spreadsheet that we'll sit down with people and they can start to fill out. But we've also learned that in order to create a process that is inclusive, the use of art is really, really useful. So here we might be asking about how are grizzly bears going to do under a particular strategy? And here Bryony has illustrated, you know, a picture of, well, when grizzly bears are in poor health, this is kind of what they look like. There's no salmon in the stream. There's no cubs. The bear is quite gaunt. Through to, well, this is what a bear looks like when it's, you know, full and fat. There's lots of fish. There's several cubs. And then we can use these images as a way to guide our experts in terms of estimating what the impact of a particular strategy might be. So we might say, you might ask, well, how are bears doing right now given the status quo? And then we might ask, you know, how are bears likely to do given a particular development scenario, a particular action? And then again, it's the difference between those two estimates, which gives us the expected benefit of a particular set of actions. So once we have our benefit, if we were to just estimate, if we were just looking at benefit alone, we'd say, oh, habitat restoration has the highest overall expected benefit. But we also need to take into account feasibility and cost. And so when we bring in those other that other information, that changes the priority of our actions. And so here, the most cost-effective single action ends up being dealing with invasive species. This is very simplistic. Often we want to know what's the combination of strategies that we can take given different budgets over time to save as many things as possible. And that's where we bring in some slightly more complex math. This is multi-objective optimization, where we're essentially saying, what is the set of strategies that I can take to maximize the persistence of species and minimize the cost over time. And using that, we can then build up a strategy for different budgets and for different numbers of species conserved. For simplicity, we've grouped our 102 species into groups with the expectation that, say, all of the migratory shorebirds are a group and that the benefit of actions will be the same for that group. So we can start and we can ask, okay, if we do nothing, if we don't take any additional actions, what's the likelihood that these groups are going to persist in 25 years' time? And we can ask this question for different thresholds of persistence. So if we just want an over 50% probability of persistence in 25 years' time, well, 5 of those groups are likely to achieve that threshold under the status quo, whereas none of the groups are likely to achieve that threshold if we raise it to a 60% probability of persistence. We can then work through and we can start looking at, well, what are the different combinations of strategies for different budgets that are going to give us the best bang for buck, if you like, till we kind of reach our optimum. So in this example, the best that we can potentially do at that 60% threshold is securing 8 species groups with this combination of strategies. What that looks like in another way is we've got, in the Fraser estuary, we have these groups of species. We have their estimated probability persistence right kind of currently under the status quo. And only 5 of those groups are likely to even exceed or meet that 50% threshold. Whereas when we look at the addition of these optimal strategies, all of those species groups now exceed that 50% threshold, and 8 of these species groups exceed a 60% threshold. There's another really important component, of course, and that's around governance. And often we ignore governance, but governance is key in decision making. Without good governance, none of these actions would have a good chance of being implemented. And that's that feasibility piece. So how do we increase feasibility? How do we increase the chance that those actions are actually going to be implemented? And in this particular example, we went back to our experts and we asked them to help us design what would be the right governance framework to support the implementation of action in this very complex region. And we worked together to develop a framework which was driven by nations at the helm. So Indigenous communities leading with the province and the federal government with the primary mandate of environmental governance. So giving salmon a seat at the table, giving orca a seat at the table. And by doing that, if we were to implement that, we then asked if that was in place, would that change your feasibility estimates? And by and large, it did. It increased the feasibility by between 10 and 15%, which thereby increased the estimates of the probability of persistence across all of the species. So for this example, we can then come up with an overall estimate of what it would cost to recover species over a particular time frame. So for the Fraser estuary, those 102 species, it's around $381 million over 25 years, or an annual equivalent investment of around $15 million a year. That might seem a lot, but if we then just do some back of the envelope calculations, Victoria is actually doing some more than back of the envelope calculations right now. That's part of the work that she's looking at. If we calculate, well, what's the potential economic co-benefit of recovering these species? Well, a Fraser fishery, salmon fisheries are worth around $300 million a year. Whale watching is worth around $26 million a year. If we were to implement all of those optimal strategies, that's around 26 full-time equivalent conservation jobs in the region. And, that's around over $300 million a year versus an investment of $15 million a year. So these analyses need to really be unpacked, and we need to start to articulate the co-benefits of investing in conservation and land revitalization actions, because we certainly industry is really good at doing that. They often, this is the first thing they'll say, well, when we build that port or we build that pipeline, we're going to create this many jobs and it's going to have this much flow on effect. We need to be doing that in the conservation space as well. So I want to just wrap up, and I want to leave it with this question, which is around, in the space that we're working in, this nexus between climate and biodiversity and food sovereignty, essentially, what are the actions that we can take to maximize food sovereignty and biodiversity while minimizing risk to climate change? That is a decision science formulation to the problem that we're all trying to solve. And I think what I'm excited about is how can my team help work with you to think about the framing of this type of problem for your specific case study. And so thank you for your time. And I hope we've got a few minutes to just have some questions. Thank you.
Thank you so much. Very interesting. And yes, there's definitely a lot of things that really connect to the core of a lot of our works that that we are doing in our research and policy engagement. I'm sure there are many questions and maybe follow-up ideas that colleagues may want to share. So I will just open the floor if you want to have a question, ask the questions, or make a comment. Please raise your hand, and I will call you out for you to speak about. Alternatively, you can also type in your questions on the chat box, and I can also read it out for you too.
Great. I see Karen asking about yeah, hi Karen. So multi-objective optimization, yeah, we can send you some good references for that.
Thank you. That'd be great. That was the details that I'd like to sink my teeth into. Working with Jake Rice and Régis Roux and Daniel Duplessis, some of my close colleagues in Fisheries and Oceans Canada, where I have been working in our climate change program for over a decade and pursuing adaptation tools to operationalize what we know and reframe the science into just tools like you're talking about. So this is really exciting work. And I see some really cool linkages around some of our work, which may or may not be coming out relatively soon. But when it does, I'll be sure to share it with this with the UBC group, because I think you'll find some interest. And I shared a different paper there too about MPAs and climate adaptation. But cool that you're talking about governance and the linkages there, because we did it's really not an analysis. It's putting data together with an observation and sharing it anyway. But I think it's an important relationship that we discovered. And so you might just take a quick look at it. It's very simple, straightforward paper. So anyway, thank you very much for the presentation.
Thanks, Karen.
Thanks. Rashid, please.
Thank you very much. And I just wanted to follow the papers you mentioned in the talk. Do we have copies? If not, can you make them available to the team? Yeah.
So how about I'll send them all to, I can just send around to the group email. Yeah.
Okay. Thank you very much.
And then maybe if we have a paper repository, Jill can add them to our repository. Yeah. Great.
It's online. Yeah. Okay. Very good. The paper, the overview paper, I would love to read it fast. So thank you.
Yeah, we'll get that out to you right away.
Well, wonderful. Thank you for the talk and for doing this. Yeah.
Oh, thanks, Rashid.
So I have questions, Tara. I mean, you talk about the maximizations, and I think one of the challenge that a lot of the conservation decision making is facing is also how to resolve the trade-offs, although that maybe people recognize that there will be an overall benefits, but the costs and benefits are not shared equally among different people, and different options may have different costs and benefits. So how should we approach that challenge?
Yeah, exactly. So I think decision science can help us to start to unpack that who is benefiting from these decisions. And because often those trade-offs are real, and the potential costs and benefits are not distributed evenly, as we know. So I think that's a really important to start to unpack that so that we can understand why certain decisions are being made. Because often it's because there's a very powerful group that is benefiting from those decisions. So how do we change that? How do we start to change that narrative? And sometimes it's by highlighting what the consequences of those decisions are. So in terms of those cumulative impacts, but it's also about identifying, well, what are some of the actions that we could take? So often we're so focused on documenting the train wreck and biodiversity loss that we're actually not thinking really broadly about, well, what are these potential solutions, and are there some real economic co-benefits of those solutions? One of the things that Victoria is looking into is carbon and the potential, carbon co-benefits of different types of actions. And we need to, so that's, to me, that's a really exciting, we need to dive into that. We need to and start to make that more visible, because maybe some of those benefits, they might not be all, they could be more like, they could be public, but public benefit could be really important. So I think that's, we're working with Indigenous communities to try to articulate, well, what could be some real benefits to those communities, not just in terms of recovery of food resources, but is there some, what are the non-timber benefits of not logging the forest? What do those look like? And are they, and are some of those monetary?
Thank you so much. Any other questions, thoughts? Emily, please.
Hi, Emily.
Hi, nice to see you.
You too.
That was a great talk. And similar to what Karen said, I see a lot of applications within fisheries and oceans. One of the questions is that that was a nice map of all of the regions in Canada where you've applied your tool. And I'm just wondering, in how many of those examples has it actually changed management? And then also, what's the follow-up to sort of monitor if there has been a change? Like, is there resources to sort of follow up and have that feedback with this approach?
Yeah, great question. So in all of those studies, yes, there has been implementation of actions. I would say that none of them have implemented all of the actions as we would have hoped, but there has been, in every case, it actually spurred on further investment from NGO sector, from private sector, from philanthropists, even from industry, and of course from government, in some, not all, strategies. We do have plans to go and actually re-elicit, like to try to quantify the actual benefit of the investments that have been made. So we're planning for my sabbatical, actually, and we're going back to Australia, where we implemented the first priority threat management. And we're going back to those same group of experts, 10, 15 years later, and saying, okay, now that we've implemented the actions, what is the probability of persistence of those species, so that we can try to quantify how good their initial estimates were, and also whether we missed something. We weren't really thinking about climate change as much as we were 15 years ago. So what have we missed, and does it matter, or would we have done the same actions anyway? Yeah. So yeah, it's work in progress. We work closely with Environment and Climate Change Canada have been partners on several of these projects. WWF Canada has adopted this particular framework as their sort of thing that they do now. And we're really keen to work more closely with Fisheries and Oceans Canada. Like, I see huge opportunity there.
Yeah, no, and I think that's great. And just one quickly on the co-benefits and carbon, and that's something that we've been thinking about with marine protected areas and the blue carbon. So yeah, that's a nice link, and I think also requires sort of that integration and follow-up monitoring. So anyway,
Yeah.
great talk. Thanks,
Yeah.
Garth.
Thanks, Emily.
Thanks. We have a comment by Ingo. So it is actually an invitation. So Ingo is wondering whether there's any chance to bring you and your team, Tara, to our next to the Costa Rica team's next project workshops. To particularly to have a decision-making training with you. And Ingo thought it would be especially useful and interesting for in the techniques in how to manage these stakeholders meetings.
Yes. Yeah, I mean, that sounds amazing, Ingo. I'd love to talk more about that with you. Victoria, myself, and another team member, Abby Kamakling, we've been developing just kind of workshop short course materials. We're actually running a workshop at the North American Conservation Biology Conference. If any of you are going, sign up for our workshop. And that's something that we want to do more of is providing training for different groups. So yeah, if there's a chance to get to Costa Rica and talk decision science, so we're there.
Wonderful, thanks. And please, if you can share that workshop in the conference with
Sure.
that, we can also circulate that. That
Okay.
sounds really interesting.
Great.
So we have another comment from Abraham. He is wondering from the decision analysis diagram, what approach do you use to evaluate the potential trade-offs?
Right. Hi, Abraham. So there's many different tools that we can use from very quantitative tools, multi-objective optimization, to more deliberative techniques. And so it really depends, again, on your particular problem, what your level of skill is, or your team's skill in doing some of these analyses. But if you have some specific examples, then let's talk offline, and I can maybe I can provide some input on what might be the best tools to use.
Thank you.
Thanks. So thank you so much, Tara. It's wonderful talks and really useful presentations. And as we said, this is a primer for a really lots of different dimensions of topics thanks also for sharing some of the references and the subsequent opportunities for training workshops. And I think some of us will be really interested in learning more about the topic. So thanks very much. And for those who are interested in the topic, I think Tara would be welcome for you to reach out to her and hope that we can discuss more about the connections between Tara's work and our projects in subsequent meetings as well. So thank you so much, and
Wonderful.
thank you all for attending the seminar.
Wonderful. Thank you. Thanks, everyone. Yeah, please reach out if you have more questions. Take care, everyone. Thank you.